All right. So today we're going to continue with quadratic inequalities. The difference today, they're not going to be in vertex form. So page 8 in your notes. And here we go. So again, standard form y equals ax squared plus bx plus c. Does anyone remember how to find the axis of symmetry? Very close. Anyone else? I heard some mumblings and just want to. It's not 2b. That would be Shakespeare, and we're not going there today. It's the opposite of b. Over 2a. And then for the vertex, that value is our x coordinate. And for the y coordinate, we take that value for x and plug it into our function. And to signify that, we call it f of the opposite of b over 2a. So a little bit more work to get to the vertex if we're in standard form. A little less work to find the y-intercept. I heard someone just say it. I know I did. The y-intercept is 0. And what's the c? And the a that's in front of the x squared acts exactly as a acts for every other function that we graphed. So we've got that value for a telling us how that affects the graph. Okay on that one. All right. So again, when we're graphing, instead of boundary line, it's really a parabola. So I maybe boundary parabola. Easy for maybe that's why I put line up there. Easier to say. Y equals ax squared plus bx plus c, using either a solid or a dashed line. Begin by finding the axis of symmetry and the vertex. Starting at the vertex, use the 1, 3, 5 pattern multiplied by a. In other words, over 1 up a, over 1 up 3 times a, over 1 up 5 times a, and so on. To plot points on the right side of the vertex, you could do it on the left as well, and then graph the symmetry for the left side. Use symmetry, or if you've started on the left, use symmetry for the right. If the y-intercept fits on your graph paper, you can use that as a point as well, and usually I do. If I can, I use it. It works out nice. Then we determine which side of the boundary to shade. And I like, how many of you use that first method? If it's less than or equal to, you shade below. If it's greater than or equal to, you shade above. How many of you use the second method? You test the point. Yeah, it's just like last hour. So this is shade below. If it's less than or equal to. If it's greater than or equal to, shade above. We could pick a point that's not on the boundary. Because if it's on the boundary, it's going to make the equation equal. So we want to pick one not on the boundary and see if that point is a solution. If it is, we shade on that side of the boundary. If it's not, shade on the other side. And it's kind of nice with parabolas because if A is positive and we have greater than, we shade inside the parabola. If A is positive and we have less than, we shade outside. And if A is negative, it's exactly the opposite. So opposite A, opposite shadings. But again, just a kind of a interesting fact, I guess. All right. Example 1. Y is greater than or equal to 2x squared plus 12x plus 11. Let's start with the easy stuff. What is the y-intercept? 0, 11. And in this case, that's not going to fit on the graph. So unfortunately, we won't have the y-intercept graphed. Then I like to list my values for A, B, and C. So what is A? 2, B, C, 11. We already said that, right? Because we had that for the y-intercept. Excellent. Once I have those values, and you know, you don't have to list them. I like to. It just helps me out a little bit. We can find the axis of symmetry. The opposite of B divided by 2 times A. So the opposite of 12, that's negative 12. And what is 2 times 2? 4. Negative 12 divided by 4. Negative 3. So that's my axis of symmetry. And also the x coordinate from my vertex. So I'm going to draw that in red. To find the y coordinate for my vertex then, I plug negative 3 in for x. So when I plug in negative 3, and again, if you have a calculator, you can certainly just evaluate that on a calculator. You don't have to do it in your head or by hand. I like to do it just to kind of get me going in the morning. Just do a couple of evaluate the values in a quadratic. So in this case, I take negative 3 and square it. What is negative 3 squared? Positive 9 times 2. 18. Uh-oh, whose phone is that? Wait, it's mine. 12 times negative 3. Negative 36. All right. So if I take 18 plus negative 36 plus 11, What do we get? All right, so -3, -7, that's my first point. In this case, A is 2. So I'm going to go over 1 up 2, over 1 up 2 times 3, which is 6. 1, 2, 3, 4, 5, 6. And then if I had room, I would go over 1 up 2 times 5. 2 times 5 is 10. But I'm already at a y of 1. So if I added 10 to that, it would be 11, and I'd be off my graph. But the nice thing is, that does verify that my y-intercept is correct. So sometimes just checking that is kind of a nice thing. Is this graph going to be solid or dashed? Solid. And should I shade above or below? Above, which in this case means inside the parabola. All right. Yes, next page. Y is less than or equal to -1/2 x squared minus 2x plus 3. What's my y-intercept? 0, 3. All right, so C is 3, if I can write it correctly. That's better. What is A? Zoe, what'd you say? -1. Perfect. So I couldn't hear you over all of the commotion out in the hallway. And B, -2. All right, so axis of symmetry, X equals the opposite of -2 over 2 times -1/2. Opposite of -2. Two times -1/2. -1. And what is 2 divided by -1? All right, and then our vertex. So we're going to go back to y equals -1/2 times -2 squared minus 2 times -2 plus 3. All right. -2 squared. 4 times negative 1/2. -2. So we started with -2. We squared it. We multiplied by -1/2. We ended back with -2. All right, -2 times -2 becomes +4. +3. -2 + 4 + 3. 5. All right, so axis of symmetry at -2. Vertex at -2, 5. Axis or y-intercept at 0, 3. In this case, A is -1/2. So I go over 1, down 1/2. This is always fun. And I get my mirror image point on the other side. Over 1, down 3/2 or 1.5. That gets me to my y-intercept. So that checked out. Over 1, down 5 times 1/2, which is 2.5. 1, 2, 2.5. Over 1, down 7 times 1/2, which would be 3.5. 1/2, 1, 2.5, 3.5 right here. Over 1, down 9 times 1/2, which is 4.5. So notice I go down 1/2, then 1.5, then 3.5, then 5.5, then 7. Sorry, try that again. 1.5, 2.5, 3.5, 4.5, 5.5. So it's just going up in this case by 1. All right. Is this going to be a solid line or a dashed line? Solid line. Let's see if I can draw a solid line. There we go. And shading above or below. Below in this case, inside, because we had that -a. All right. Next example. F of x is greater than -x² plus 2x. So the first thing, again, I'm going to write this as y is greater than -x² plus 2x. What is my y-intercept? 0. There's no value for c. So c is 0. Our y-intercept is at the origin. Axis of symmetry. Oh, wait. A, B, C. A is -1. B is 2, and we already said C was 0. Now axis of symmetry, x equals the opposite of 2 over 2 times -1. So the opposite of 2, that's -2. 2 times -1, -2. And -2 divided by -2, 1. So for my y value, I plug 1 in for x. One squared. 1, that's a tough one, I know. Opposite of 1. -1. 2 times 1. 2. And -1 plus 2. So our vertex is at 1, 1. All right, sketch some of this in here. Axis of symmetry. Vertex. Y-intercept. So from the vertex, A is -1, so I go over 1, down 1. Then I'm going to go over 1, down 3. Over 1, down 5. Solid or dashed? Dashed. Should I shade above or below? So we shade all of this. All right. So as soon as you've shaded to your satisfaction, go ahead and do the try now. And if you're watching this video, go ahead and pause. So, what is our y-intercept? 0, 2. Excellent. What about our axis of symmetry? X equals 2. A lot of 2's in this one. Then our vertex is the point 2, -2, lots of 2's in this one. So here's the, there we go. Come on, there we go. There's the work for that. All right, so we graph that. The nice thing, A is 1, so it's over 1 up, 1 over 1 up, 3 over 1 up, 5, and so on. For this one, are we going to shade above or below? Below. And is it going to be a dashed line or a solid line? Dashed. So my goodness, I hope it looks like that. The last thing I would like you to do before I hand out homework, take out your Chromebook or your device. I just want to make sure we can all find the map testing site. It's pretty easy. I'll kind of walk you through it. What you need to do is, if you're already logged in, you need to log out. So you get to that screen with the white background. And in the lower left-hand corner, after you get to that screen, it'll take a second or two. You'll get the apps menu. When you click on the apps menu, the app that you want is the NWEA lockdown browser. It's like the third one down or fourth one down in the apps menu. And that's where you'll go tomorrow. And so the thing that I would love to see is when you come in tomorrow, pop open your device, go to that app and have it up and ready to go. Then I will give you the login, session name, and PIN number. If you go to that site now, it's not really helpful. It just asks you for the session name and the PIN, but you can click on the X in the upper right and it'll take you back out.